All right, quick reintroduction to quadrants and points and things here before we actually get into distance and midpoint. Just a reminder up here at the top, anytime you've got a point over here in this first quadrant, both your x and your y values, of course, are going to be positive. And as you move your way around, okay, as I go to the left, it makes sense. My x's become negative. Y is still positive because I'm up. And as I move my way around, -4, -1, left is negative, down is negative, okay? And that's a general rule whenever we're dealing with coordinate points. So when we get into something like plotting coordinate points here, we're not going to be plotting coordinates, but I want you to be sure you understand, if I happen to give you a line, how to find the points, because otherwise it's kind of hard to do distance and midpoint. So for instance, for A, I go left 2 and up 3. I always do the x value first and the y value second. That's never going to change. And it's just the general movings that we normally do. And then the nice thing is, most of the time with a graph, not every time, but most of the time, you're going to have some sort of number to use as a reference. So here, well, these numbers look positive. So I went +5 to the right, +2 up. And I'm just going to do that quickly for these others. So right 1 and down 7. And it's just an understanding, left 4 and down 5, right 3, down 3. And then here, this is the one I got to be careful on. I went left 8, but I didn't go up or down any. So understanding how the coordinate points come about is important. Also understanding the directions to know what the value should be, positive or negative, is important. Because when we're talking about quadrants, okay, number 1's always in the upper right, and it sort of goes in a big C shape. So quadrant 2 is directly to the left. Quadrant 3 is right below. And then quadrant 4, and you can just use numbers if you don't want to use the Roman numerals, that's fine too. But it always goes 1, 2, 3, 4. That never changes either. So if I label them, that makes the next part pretty easy. Okay. A is going to be in quadrant 2. B looks like it's in quadrant 1. C, oh, C. Is C in a quadrant? No. It's on the y-axis. If it's on one of the axes, okay, it's not in a quadrant. I don't want to say it's in quadrant 3, 4, okay? I just want to make sure I get that situated. D is going to be in quadrant 3. E would be down here in quadrant 4. And then G is a similar situation to what we had here with C. G, I'm on the x-axis, and I found that point. So again, when I'm labeling, that wouldn't necessarily be in a quadrant. That would be on an axis instead. That would be something that I'd work with that. So then if I wanted to plot points, which we were going to do a couple here, just to kind of make sure we got the point. If I wanted to graph the point 7, 10, what directions would I be going and how many? Okay, right 7 and up 10. Make sure I get on the right dot here. Okay, so there'd be my H. J, -5, 12. Okay, so left 5, and then the second number is always my up or down. You're like, up 12, can't even go up 12. Well, we'll get creative here. And then correct. That first number is always my x. It's always a left or right. So left 1, and then down 8, and that would be my value. So just get my point situated with that. So then I can use that knowledge to do the next two things we're going to talk about. Now when we're looking to find distance, I'm going to show you two ways that you can do it today. Well, technically there's three, but there's two main ones. If it's a horizontal or a vertical line, and again, horizontal is just side to side, vertical is going to be up and down. We call it the ruler postulate because I can just count how many squares or how many spaces there are between the points. That doesn't happen real often, but it's nice when it does because that's easier. But if it's not horizontal or vertical, if it's got a slant to it, we're going to use the distance formula Or we can use the Pythagorean Theorem if you've got some introduction to that, which is more visual. So I'm going to show you both today, and hopefully you can find one that works pretty well for you. So, as we flip over here, and this will be a handy thing to have when we have our quiz too. Okay, so the distance formula, if I need it, the distance between any 2 points is given by this. So I take the x's, minus them and square it, take the y's, minus them and square it, and then I add those together. So here's what I'm talking about when I can do it one of 2 ways. If I use the formula, I'd be like, okay, let's see here. My x values are 5 and 4. So I'd minus those and square it. And then I'd add the difference of my y's. So that's 2 and 1. So 2 minus 1 squared. And I can do all of this in the calculator, but here's the one kind of caveat or warning I would put out there. I personally wouldn't try to do this all at once because it's that same parenthesis issue we were talking about before. So what I would do is I would do the stuff underneath. So 5 minus 4 squared plus 2 minus 1 squared. Okay, notice I'm not doing the square root quite yet. I'll get an answer. And then I'm going to take the square root of whatever that answer is. And as you can see, we can get decimals. Okay, so I could either leave the distance as the square root of 2, or I could say it's 1.41. It doesn't matter. You're like, but what if I don't like the formulas? What if I always screw up something with the formulas? Is there another way? And there is. And I'm going to show you that way right about now. The other part they talked about was using the Pythagorean Theorem. So if I was going to do that, I'd take a graph like this, and I'd say, okay, and I might have to sketch a graph if I didn't have a drawing here. So 5, 2, and 4, 1. Now it's a little bit trickier with this one because that's squished in so much, those 2 values together. But normally what I could do is I could do what's called the Pythagorean Theorem. And here's how that would work. Wish I could jumbo size this, but I can't. To get from this point to the other, I could actually make a triangle. So to get from here to here, I'd go right 1. So I'd have a side of 1, and I'd go up 1. I'd have another side of 1. So if I drew that triangle out here where I can see it a little bit better, I know this side is 1, I know this side is 1. My actual distance is the other side of the triangle that I haven't found yet. So I mean, you've probably heard the Pythagorean Theorem before, even if you're not thinking of it right now. It's a squared plus b squared equals c squared. My 2 legs, which is what the sides of my triangle are called, would be my a and my b. So I'd just do 1 squared plus 1 squared equals c squared, or x squared, I could call it here. 1 squared is 1, so 1 plus 1 is 2. And I don't want it squared, I just do the square root, and I get the same answer. So if you're not a fan of formulas this way, you could just do the a squared plus b squared equals c squared. That's easy enough to remember. A little bit easier than all that stuff, but either one works. But again, that was a little bit trickier since the points were so squished together. Maybe this next one will be a little bit easier to play with. So let's try it both ways one more time. So if I do it with the formula, and again, you'll always have access to the formula because it's here in the notes, and you can use the notes on any quiz or test that we do. So I'm going to get all my information in here. Yeah, this triangle will be bigger, so you'll be able to see it on the graph a little bit easier, because that one was kind of tricky to do. So here, my x's are -3 and -4, and my y's are -5 and 6. So again, when I get ready to go to my calculator here, I'm going to type in exactly what I see, minus the square root sign, of course. So -3 minus. Now, let's talk about this for a minute. Maybe we can clear this up a little bit. I'm going to clear this off for a minute. What happens when you minus a negative? Okay, so this is really plus. So when I go to type it in, I'm going to type in negative 3 plus 4 squared, because I don't want all those extra parentheses, plus negative 5 minus 6 squared. So here my distance would be the square root of 122, or if I wanted to go to the decimal, I could say it's 11.05 if I'm going to round correctly here. Okay? Either of those are perfectly acceptable. But this time it's going to be easier to see if we try our Pythagorean Theorem idea out here. So let me just bump this up a little bit. So here, if I plot my 2 points, negative 3 left, negative 5 down, negative 4 over 6 up. Here's how this would work. I'm trying to find this distance. However, I'm attempting to do that when I grab another color here. I would make a triangle. You're like, that's one skinny triangle, Hardy. So again, I'll kind of draw it here. And I notice down here at the bottom, it only goes 1 wide. Okay, so I'd get my 1 in there. But it goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which again is hard to see because my line gets in the way. So I'd go 1 over and 11 up. And you'll notice a pattern develop here. 1 squared plus 11 squared is going to be my distance. And if I add up 1 squared and 11 squared, there's that 122 again. And I do the square root and I get the same answer again. Whether I do that or I punch the number in and I get the decimal. So you have a choice on any of these. I'm never going to tell you you must use the formula, you must use the Pythagorean theorem. You're always going to have that option. And you can always figure out which way you want to do that. So as far as distance goes, that's the way that we'd run this. However, okay, I'm going to skip the congruency statement at the bottom. We're going to flip over for right now. We're going to do something a little easier here. All right, but then the other one's midpoint, which is an average of points. So if they tell me to find the midpoint between A and D, okay, here's A, here's D. All I would do is I would add those two values together and divide by 2. So negative 8 plus 0 is negative 8, divided by 2 is negative 4. And to be perfectly honest, if I have a number line, I could just use my fingers until they run together in the middle and find that same value, okay? So if it's on a number line, that's pretty straightforward and easy. But what if it's on a coordinate plane like it is down in the next part? The theory works the same way. I'm going to add up my x's and divide by 2. I'm going to add up my y's and divide by 2. So if I went straight by the formula, which is definitely the easier way to go with these, my x values are 3 and 7, so I'm going to add those up, divide by 2. Notice the parentheses up top, and yes, I need them. We'll talk about, again, why we need those in just a second. And then my y's are 5 plus negative 9 divided by 2. So just as a reminder, just to see why the parentheses are important here again, if I use the parentheses, which is the correct way to do it, okay, I get 5. Well, let's say I forget, and I do 3 plus 7 divided by 2. Oops. Because the calculator, if you don't tell it, is going to divide before it adds. It's following order of operations. It's doing it the right way. So whenever you're trying to do one of these, you either need to put parentheses in, or if you wanted to, you could do 3 plus 7, and then hit enter, and then hit divided by 2, and you'd still get the right answer. But you need to do it one or the other. So like here, if I want to do 5 plus negative 9, enter, and then divide by 2. Okay? That's going to get me the correct answer here versus, maybe I do 5 plus negative 9 with the parentheses, and I get the same thing. It all depends on if you want to do it in one step or two. But midpoint, I would never suggest trying to do it on here, trying to do it on the grid, because it's just not easy. Okay, this is going to be much easier. So again, midpoint is just like finding an average. I'm always dividing by 2, that never changes. And again, the only important thing here is I got to make sure I use the x's first. Negative 2 plus 10. And then I use my y's second. 12 plus negative 4. Or I could just do 12 minus 4. So negative 2 plus 10 would be 8. Divided by 2 is 4. 12 minus 4 is 8. Divided by 2 is 4. Again, definitely want to go formula on that because it's an average. What number's in the middle? I could even, if I wanted to, draw these numbers out on a number line like the first example and then count to the middle to find each one. It might take a little longer, but if that's easier for you and visually appealing, I say go for it. So the last thing, because there's always got to be one more part to this. Okay. Use the midpoint formula to find the missing endpoint. This is where you're going to have to read carefully, because sometimes I might not ask you for the midpoint. Sometimes I may give you the midpoint. The midpoint of AB is 3, 4. One endpoint is negative 3, negative 2. Find the coordinates of the other endpoint. So here's how this is going to work. Normally, when I'm looking for this, if I want to find the midpoint for my x value, I add up the x's, okay, and I divide by 2. When I want to find the midpoint for y, I add up the y values, and I divide by 2. So here's what I'm going to do this time. They're telling me what the x value of the midpoint is. It's 3. So I'm going to plug that in for midpoint of x. They tell me what one of the endpoints is. It's negative 3. So the only thing I don't know is what's that other x value? What's the other x value of my other endpoint? I'm going to do the same thing for y. And then I'll solve this. My y value of the midpoint is 4. My y value of my endpoint is negative 2. So you're like, okay, so this basically is going to turn into an algebra problem. Yes. So we're going to kind of take our step here, and we're going to bring it down on these. If I want to solve for this, how do I get rid of a divide by 2 fraction? What's the opposite of dividing by 2? Multiply. And this will be the first step every time on both of these. That will never change, because the 2's just cancel here. So I'm left with what's up in the numerator. And 2 times 3 is 6. Same thing on my y. Those 2's will cancel. Don't distribute. Don't do it. 2 times 4 is 8. Just rewrite what's up top. And now I've got a one-step equation on each one. Okay, so I'm going to have 2 steps with these. Here, since I'm negative 3, I got to do the opposite and plus 3. So 9 would be my x value. Over here, yep, I'm going to add the 2. 10 would be my y. And my answer, whoops, I got to move that up or it's not even going to fit. My answer is always x first, y second. Never changes. The only difference in this whole thing, I'm still using the midpoint formula. It just depends. If they tell me the midpoint, I've got to do the algebra part. I can't just plug it into the formula and be done. And so just to make sure, I want to do one more. then I will leave you alone for a while. So again, they give me the midpoint, they give me one of the coordinates. So again, my job, and I'm just going to rewrite this one more time here, just so I've got it in a couple of places. I'll get to a point that I won't have to write this step out. But for right now, got to be sure. Okay. So I look and I say, okay, the midpoint. My x value is 4. Okay, I'll plug that in. One of my endpoint x values is 2. So I replace one of the x's with a 2. I don't know the other one. So I make my equation. For my y's, the midpoint value of y is -6. So I plug that in for my m value. My y value in one of my coordinates is -3. So I plug that in. So once I get to here, now again, it's strictly a battle of finishing off the problem. So I look in there and I go, okay, let's see. My next step always is to multiply both sides by 2, because I want to get rid of the fraction. And that's going to be the same on both sides of my equation. So 2 times 4 is 8. And those just canceled, so I'm left with that's up in the numerator. Same thing on this one. The 2 is canceled. 2 times -6 is -12. And I copy what's left. And now it's just a one-step equation that I'm working with. Since that's a positive 2, I'll minus the 2. That's 6. Since that's a -3, I'll add the 3. That's -9. And then I just write it in as a coordinate. So just to give you a little bit of a heads up on what examples will help with which problems, if we keep referencing back to the note sheet, okay, it mentions when you get into the homework, use the distance formula or Pythagorean theorem to find the distance. So when you're looking at examples, okay, you would use example 1 or example 2 to help you on this first part, okay, and finding your distance. When you get down to the second part here on the bottom, where it says find the midpoint, you would use example 4 or example 5, because that's where the formula is at. And then finally, when you get over to the back, I give you one of the endpoints and tell you to find the other one. That would work the same way as examples 6 and 7 do. Tomorrow we'll be working on this one more day, make sure we're feeling good with it. And then I think Friday, because I don't like doing Monday quizzes, Friday we might do probably a little quiz just on some of this stuff as we start heading towards the end here. So that's about it.